This is 2008 paper, and we're doing question 2. So just have a look quickly, and then we'll talk. So looking through all of this, it seems pretty complicated. But something important to know is if we have a circuit going through like this, and this is just one set of circuit in series, yeah, there's other parallel things, but this is just one way it could pass. The voltage doesn't split, so we know it must be 6 volts up here, and then by the time it gets to the bottom, it's 0 volts. Over here, maybe some current splits, but 6 volts is still going to go down this way, and 6 volts is still going to go down this way. So, if we know that, we can just look at this part of the diagram. This is not connected, there's no input signal. Yeah. So, it looks like this. And I ask, what will the value of the DC voltage be between P, so that's 2 and that's 1, and this is point P, and F. So I want another voltage drop across here. And this looks very much like our voltage divider formula. So let's just bring that out. Voltage divider formula there. And apply it to our situation here. The resistor we want is this one, so we'll put that on top. The total resistance is 1 plus 2 is 3. We multiply it by the V in, 6 volts, and that gives us the V out here. So that's 2 volts. 2. Still with no input signal. The current through RC is measured to be 3 milliamps. RC is 3 milliamps. So we want the voltage between Q and Earth. Q and F. So we don't have much information about Q and F. But they gave us this line, and that's usually a hint. And once we read this line, we think, hey, I can figure out the voltage of that. It's just voltage equals current times resistance equals 3 times 10 to the negative 3 amps, because it's a milliamp, times 1000 ohms. That equals 3 volts. So we have a 3 volt voltage drop across here. And if it starts at 6 up there, and we subtract 3, we have 3 left over here. So that's the voltage drop. What is the power dissipated in resistor RC? So we have RC again. And we know 2 things about it. We know the current, and we know the resistance. So we can just use our formula, power equals I squared R. I'll quickly show you all the power formulas. Here they are. So if you had the current and the voltage, you could find it. If the voltage and the resistance, you can find it. The current and the resistance, you can find it. You just need 2 to find the power. P equals I squared R, which equals, do this on calculator, guys. I just don't know how to use a calculator, actually. I've been practicing, but I don't know, it's just really hard for me. 3 times 10 to the 3, and then I cancel that, that becomes minus 3. So we get 9 times 10 to the negative 3. I give up. I'm not going to even try anymore. I'll try again later. Okay. Oh, that's it. Great.